topics. The title of the topic is measurement technique, and you can see the year number, and once you copy the year number, you can read the question first. This is measurement. Now, you have read the question. They have given a data. They have given the value of V upon T. They have given a value for pressure R and L, quite a big set of data. Calculate the value of C. So what I have done, I'm keeping V upon T. I'm not breaking it during the rearrangement because V upon T is a fraction and it's appearing as a single entity in the table. So I have rearranged it, and then I have made C the subject. First, you copy this, and then you can help me to find the value. Okay, you have arranged it, and you can now use your calculator to simplify the value for C.
I'm getting 1 into 10 power minus 3 as the answer.
1 into 10 power 3
Minus 3.
minus 3. It looks fine, but let's see. Anyways. Now, second part, examiner says uncertainty We have ignored the constants. First, write down the formula. Then we should move C on the left-hand side. Do not break V and T. They keep them together, and because we need it, it's a single entity. Now it's up to here. Now this is a test of patience because we have to put all these values. Here unit conversion doesn't matter because it's a fraction. This question is actually giving a lot of data, including unit conversion, but now unit conversion is not important. Deba P upon P. So it's 0.05 upon 2.5. Or Deba R upon R. 0.01 upon 0.75. So V upon T is 1.2.01 upon 1.2. And we have the value for C. This is a big calculation. First, we need to carefully enter all the values so our presentation is complete.
I'm getting 8.6 into 10 power minus 5.
Can you repeat please? How much?
8.6 into 10 power minus 5.
Now it is going to be uncertainty 8.6. So uncertainty should be given correct to 1 sig fig. So I can make it 9 into 10 to the power minus 5. Now he says a very clever question, state the value of C and its uncertainty to the appropriate number of sig fig. When you have to write them together, it would be necessary to maintain the same number of significant figures. It would be necessary to maintain the same number of sig fig. This is possible on, I'm sorry, same numbers, I'm saying same power of 10, because otherwise I can't write it together. I have to take common. So C is in power of minus 3 and here it is 10 power minus 5. So let's make uncertainty 10 power minus 3. I have to combine them. I have written it like that. Define electrical resistance. You can define electrical resistance from the formula R is equal to V upon I. So resistance is defined as the potential difference across a conductor per unit amount of current. This is the definition coming from the formula. A circuit is set up to measure the resistance R of a metal. The PD, V across the wire and the current in the wire are to be measured. Draw circuit diagram of the apparatus. Here, this belongs to this topic. How come? This looks to be a current question. Acha, okay, fine. He comes after that. So make a circuit diagram to make these measurements. So we can design a circuit. Ammeter always comes in series. Ammeter always comes in series. And voltmeter always comes in parallel. So this is a circuit. This is a circuit. So copy down this circuit. It's a simple circuit. And
I've copied it.
good. Now examiner says that readings for PD, V and the corresponding current I are obtained. These are shown in the figure. So it looks to be a best fit line. They're showing some random error also. Explain how figure 2.1 indicates the readings are subject to systematic uncertainty. It's can you tell me from the theory how I can say there is a systematic error?
Because the reading does not start from 0.
Yes, there is an intercept. Very good answer. There is an intercept. What about random error?
Maybe the readings are not aligned.
Somehow the right thing. The fluctuations in data, scatter diagram. He says use your data from 2.1. 2.1 is I against V. Looks to be a gradient case. I'm going for the idea of gradient. Now you see this one. I can make a triangle or something like that. I'm stopping at one box before the last box. I'm thinking to make a triangle because you have to take the points as far as away as possible. Now I have tried that idea. So one value is, oh, one value is 0.05. Now, if I take this value, how much it would be? 0.25 till 0.30. It means 0.05. And there are 5 division. So can you let me know how much one division would be here?
0.01.
0.01. So where I am touching here, this position. This one. So it's 0.01. So it means 0.25, 0.26, 0.27. No. It means 0.27. So I have now the numbers. Now here on x-axis, one number is 0. What about the other number? Is just before 5. I'm taking it 4.9. Now you take out the gradient for me. 0.27 minus 0.05 upon 4.9 minus 0.
I'm getting 0.448.
0.448.
0.0448.
Oh. Okay. 0.0448. Let me know if you get the value.
It gets 22.27 with this. So that will be rounded to 22.3.
You are saying 22.27.
27.
How we have to see the data in the question, how much sig fig they are using. They are using 2 sig fig. They are using 2 sig fig throughout. So we can write 22 then. Anywhere are they using 3 also? No. Part number C, In another experiment, a value of R is determined from the following data. Calculate the value of R together with its uncertainty. Give your answer to an appropriate number of sig figs. So we can start our working again by the formula R is equal to V upon I. First, we are calculating the absolute value.
I'm getting R as 10.625.
So we can now take it here. See how much uncertainty comes now.
It's coming 0.33.
0.33. Uncertainty should be given correct to 1 sig fig. So if you take R as 10.6, this is how we write the answer. A cylindrical disc is shown in the figure. The disc has diameter 28 and thickness 12. The material of the disc is density this. Cylindrical is the shape. The weight of the disc. Density is equal to mass upon volume. And we know the formula of volume of a cylinder. We should first try to find the volume. This is the formula. Volume is equal to pi r square h. I have diameter, so I put the diameter here. Diameter is 28 millimeter. And thickness or height is 12 millimeter. Then we have found the mass.
The mass is coming as 3.6 kg.
3.6 kg. Then we have to convert it into weight. So into 3.9, sorry, 3 into 9.81.
It comes 35.3 Newton.
How much sig fig? He's taking 2 sig fig. Now we have November 13. This is a question on CRO, and I have already made a video on questions on CRO, which can be observed when questions, special cases when CRO and topics like relative speed, etc., are important to be revised. A source of radio wave sends a pulse towards the reflector. The pulse returns from the reflector and is rejected at the same point. The emitted and reflected pulses are recorded on a CRO. The time-based setting is 0.20 microsecond per centimeter. Determine the distance between the source and reflector. Signal has gone and then returned. It's a case of echo. This is a case of echo, and You can count them 1, 2, 3, 4 divisions. There are 4 divisions and 0.02 microsecond per division. So I can find the time 0.20 into 4. It will be 0.80 microsecond. Now we have the time, we have the data, so we can put them to find the distance. If the signal is a radio wave, the radio waves travel with the speed of light. So I made these steps.
It is coming as 120 meters.
120 meter. Okay. Determine the time-based setting required to produce the same separation of pulses on the CRO when sound waves are used instead of radio wave. The speed of sound is 300. So he wants to make the same separation. Speed has changed. So we can use a ratio method because other factors are same. D cannot change, time will change, and it was, our scale was 0.20 microsecond. So I can, what I should do, I should take a ratio. Because other factors are same. So when it was 3 into 10 to the power 8, I had 0.02 microsecond per centimeter. So when I make it 3 into 10 to the power 2, which is the speed of sound, I make it x. Can you help me to find this value?
It is coming as 2.2 raised to the power minus 14.
Minus 14. I made a mistake. It's 0.20. It's not 0.02. So I think the power of 10 would change a bit. Please double check the calculation now.
Now it's coming as 2.2 into 10 raised power minus 13.
Yes, 13. Okay, let me try. If I remove the micro, something is going wrong, because then this is too small. Something is going wrong because I'm using a direct ratio. Now I have made a mistake because it was a direct ratio case. It was not a direct ratio case. It was inverse ratio. When speed is decreasing, the setting will increase. The rule of graph, when you want to plot bigger number, you have to take a smaller scale and vice versa. So the ratio between speed of light and speed of sound, speed of radio wave and speed of sound is 10 power 6. It's 0.2 microsecond per centimeter. So I have taken it and I've removed the micro 10 power minus 6. And then I have taken the new setting, which is 0.2 S per second. So you have to see this rectified working.